Math with Nazia. In this video, we are going to learn the relationship between HCF and LCM. I have already taught how to find LCM and how to find HCF in my previous videos. You can refer that and the link will be given in the description below, and have already explained how to find the relationship between LCM and HCF. That is also been explained in my previous video. You can refer that. I will put the link below in the description. And now let's take few important questions of CBSE syllabus. So this question was asked in 2019 paper. So let's see the question. On a morning walk, 3 persons step out together and their steps measure 30 cm, 36 cm, 40 cm respectively. What is the minimum distance each should walk so that each can cover the same distance in complete step? So all this has been given. What is to be found out? We have to find out the distance now. How much distance is required? So to find out the distance, first we have to find out the LCM. So whenever this type of question is given, first we have to find out the LCM of 30, 36 and 40. So let's find out the LCM of 30. So how will we find out the LCM of 30? I think you all remember the prime factorization method, which we have already learned. So when we do it, 30 is divisible in, it is divisible in 2 table. So it is 15. Now 15 is not divisible in 2, but it is divisible in 3. So 3 times 5 is 15 and 5 times 1. So now what we have got for 30 is 2 times 3 times 5. We have got this. Now let's find the LCM for 36. So how are we going to do the LCM for 36? The same method. 36 is divisible in 2 table. 2 times 18. Then 18 is again divisible in 2 table. 9 is divisible in 3 and then 3, 1. So we have got the prime factorization of 36. That is 2 times 3 times 3. So we have found out for 36. Now let's find out for 40. We will follow the same method. 40 is divisible by 2. We get 20. 20 is further divisible by 2. We get 10. 10 is again divisible by 2. We get 5. Now 5 and 1. So 40, we have found the LCM for 40. So 40 equals, we have 3 2's, 2 times 5. So we have like this. Now let's find the LCM of this. So instead of this, you can write like this. The LCM, we will take the common numbers we will take, or we will take the highest powers in each. So this we can write it as 2 times 3 times 5. But this can be written as 2 square times 3 square. And this can be written as 2 cube times 5. So this is what has been found out. So LCM equals, we will always take, whenever we are doing LCM, the one thing to remember is we will take the highest powers. So for 2 the highest power is 3, for 3 the highest power is 2, and for 5 the power is 1. So for 2 the highest power was 3, so let's take 3, so it is 2 cube, and for 3 the highest power is 2 and 5. So this is the way we find out LCM when we have the prime numbers. We will take the highest power. So 2 cube is 8, 3 square is 9, and then 5. So when we multiply 8 times 9 times 5, we get 360 centimeters. So this is the distance. This is the distance covered. This is the distance covered by the 3 friends. So isn't it easy? We just need to find the LCM of the 3 numbers given, and that is the distance. So now let's see the second question for today. Now now the second example is show that 12 power n can never end with the digit 0 and 5 for any natural number n. So this is an important question. This was asked in 2020 paper. So this question was asked in 2020. This is a very important question. Show that 12 power n can never end with the digit 0 or 5 for any natural number n. So if we have to find that we don't have any numbers which will end with 0 and 5. So first we have, what do we have? We have 12 to the power of n. So now let's find the LCM for 12, or let's prime factorize 12. So when we do the prime factorization, 2 times 6 and then 2 times 3 and then 3 times 1. So this is our prime factorization. So here we would be getting 2 square times 3 the whole power n. So as you could see here, we will remove the brackets. So when we remove the brackets, we will use the exponent law. So here we can write this as 2 to the power of 2n times 3 to the power of n. So n is being multiplied even for 2 and for 3. So here we get 2 to the power of 2n times 3 to the power of n. So by this we will know that therefore 5 is not a factor. It is not a factor. So since 5 is not a factor, this will never end with 5 or 0. This digit will never end in 5 or 0. It's a very simple question. We just need to find the LCM, find the factors of it. So we don't have 5 as a factor. So this will never end up with the digits 0 and 5. So now let's see the third example for today, which is find the HCF and LCM of 404 and 96 and verify. So here this question was asked in 2018 paper of CBSE exam. So we have to find the HCF and LCM of these two numbers and we have to verify that. So to verify, we have a formula, like I have already explained this formula. HCF times LCM equals A times B. That means the times you have to multiply HCF and LCM and you get the product of the two numbers. So first let's find the HCF and LCM of 404 and 96. Here again we are going to use the same method, 404. Let's find the prime factorization of that. So this is divisible in 2 table, 202 times, then this is divisible in again in 2 table. So we get 101. 101 is a prime number. It is not divisible in any table. We will directly write this as 101. So the factors of 404 are 2 square times 101. Now let's find for 96. So 96 is divisible in 2 table. We get 48. 48 is again divisible in 2 table. We get 24. 24 is again divisible in 2 table. We get 12. And let's see how it is further divisible. So let's see how it is further divisible by 2. So it is divisible 6 times, and again it is further divisible by 2, 3, and again it is divisible by 3, 1. So now we have found the factors of 96. So 96 equals 2 power 5 times 3. We have only 1 3. So as I told you in the previous question, for LCM we will write the highest power. When we find the LCM, we write the highest power, which is 2 power 5 times 101 times 3. For HCF, we will always write the smallest power and which is common. So here 2 square is common. So HCF is 4. Let's find the LCM. So LCM is 2 to the power of 5 times 103 times 101 times 3. So we get an answer of 9696. So the LCM of these two is 9696, but the HCF is 4. So now let's use the formula H times L equals A times B. So H is 4. 4 times 9696 should be equal to 404 times 96. So when we multiply these two, we get 38,784, and when we multiply these two, we get again 38,784. So now these two are equal. So we have verified that LCM, the product of LCM is equal to the product of the two numbers. So isn't it easy? We will just, as usual, we'll find the LCM and HCF using the prime factorization method, and then we will use this formula H times L equals A times B. So now let's see the third example for today, which is, so the fourth example for today is two positive integers A and B can be written as A equals x cube y square and B is xy cube, whereas x and y are prime numbers. So we know what is A. A is given as x cube y square and B is given as xy the whole cube. So as usual, we can find the HCF, but what is given, x and y are prime numbers, so we can't further simplify it. They are telling us to find the HCF. This is a pretty easy question. This question was also asked in 2019 paper in CBSE exam. Very easy question. So they are telling us to find the HCF. So it's very easy. I will teach you how to find the HCF and the LCM. So how to find the HCF? The HCF is always the common number. So what is common in x? X is common. And what about y? In y, which is common? Y square is the smallest term, so that is the HCF. And if you want to learn how to find the LCM, I have already taught you the greatest power is LCM. So x greatest power is x cube, and for y the greatest power is y cube. So this is our HCF and this is our LCM. Isn't it easy? To find HCF, we will take the smallest power common number, so we will take the smallest power, and for LCM we will take the biggest power. So if you have any queries regarding these type of questions, you can comment down in the comment section, and for more tips and tricks, do like and subscribe to my channel. Thank you.